Today we're going to do arcs and chords. So arcs and chords, first off you need to know what a central angle is. A central angle is just what it sounds like. It has to be at the center of the circle, okay, and it's an angle. So the vertex is the center of the circle. An arc is the sides of the circles. And so the sides of the circles are the different arcs. We have a major arc and a minor arc. The major arc is the longest arc connecting two endpoints on a circle. And then the minor arc is the shortest arc connecting the two endpoints of a circle. So like AB going this way would be a minor arc, but ADC going this way would be a major arc. So I kind of think of them like if they're bigger than 180, then they're the major ones, and then if they're smaller, then they are the minor. Okay. Arc addition postulate just means if I ask you for AC and I tell you that AB is 20 and BC is 30, then you should know that AC is right, 50. Exactly. All right, so and then you're supposed to know that together the whole thing in a circle is 360 degrees all together. So like here on this example, it asks us to find something else that they missed. The central angle and the arc are equal to each other. So like since this angle here, this central angle is 93, this arc AC is also 93. So right here, when it asks us to find arc HJ, it would be 63 degrees. And then it asks us to find arc, the measure of arc FGH. So that's FGH. So I need this one to finish. So since I know this is the diameter here, I can do 180 minus the 65 and the 63. To get 52. So then I would add 65 plus the 52 to get 104 degrees. Okay. All right, I want you to try number 3 and number 4. Press pause so you can try number 3 and number 4. All right, I know y'all got that done. So now we have the measure of arc CDE. Arc CDE. If you notice, remember vertical angles, we haven't talked about them in a while. So these angles right here are equal. So therefore that one's 40. So if you look at arc CDE, it would be the 40 plus the 90. So it would be 130. And then it asks for arc BCD. So that's BCD. So I'm going to have to subtract. This would be 90 here. So 90 minus 40 gives me 50 here. So that's 50 plus the 90. So that would be 140 degrees. Okay, press pause again and go ahead and do number 5 and 6. Wait, 5 and 6. All right, so then on this one, I know you got those correct. Okay, I believe in you. So we have arc LMN. And so we would have had to subtract the 30 and the 105 from 180. And that should have left you with what? Yes, 45. So that would have given you 45 right here. So you'd have 45 plus 30 to get 75 degrees. And then the last one is LNP. So that goes all the way around like this. So that would be the 180 degrees, half the circle, plus 45. So that'd be 225, major arc. Really, like if it has 3 letters, it's a major arc. So LNP is major, LMN is major, HJ is a minor. Okay. All right, so that is arcs and chords. Next, we're going to do sector of a circle and arc length. All right, so now we're doing sector of a circle. So think of it like area, but just a piece of it. So like if you had a piece of pizza with like a whole pizza and you had just picked up one little slice and you want to know how much pizza you had, okay, out of the whole pizza, you would have to do sector area, sector of a circle, okay? So the formula is A equals pi r squared m over 360. M represents the angle measure, okay? So all the central angles we were just doing, that's what M represents. So like here on this formula, on this example here, I'd plug into my formula. So A equals pi, my radius is 6 squared, times 70 divided by 360. And it says round to the nearest hundredths place. So I would put that in my calculator. So pi times 6 squared times 70 divided by 360. And think about it like this. So like this is the first part of this formula is the area of a circle. But since you don't want to know the whole circle, you only want to know a piece of it. That's why the M over 360 comes from. So that would give me 21.99 centimeters. And since it's area, it is squared. Okay, you go ahead and try number 2. Press pause, and then you can try number 2. So A equals pi 9 squared 120 over 360. So I put in my calculator. So that would give me 84.82 inches squared. And that is sector of a circle. All right, now the last thing we're going to do is arc length. So circumference is like going around the whole circle. But arc length is just finding the distance of an arc length. Instead of finding the whole distance around, it's just a part of it. So notice that the formula has circumference of a circle times just the part you want to know the length of. So again, I just plug into the formula. So A equals 2 pi 18 110 over 360. Okay, so when you put that in the calculator, you should have gotten 34.56. 34.56.
No, I didn't say nothing.
Inches, and since it's like circumference, you don't have to put squared, okay? So 34.56. Okay, you could try number 6 by yourself. All right, so I'm not going to do this one with you because, like I said, it's the same thing. You're just plugging straight into the formula. The radius is 14, and the measure would be 90. But I do want you to see how to do it in radians also. So remember, we always talked about radians. So like here in the book, you can see angles can be measured in units that are based on arc length in the radian instead of degrees, okay? So the arc length in radians would be theta equals L over R. Theta, remember, that means angle. L is the length of the arc. So this isn't slant height, it's the length of the arc. And then the radius is, of course, the R. So for example, if I did an example like this. All right, so this is the example here. So I will plug into the formula. The 3 pi divided by 7 would be my theta. So I'd have 3 pi divided by 7 equals, of course I don't know the arc length, I'm looking for it. And my radius is 5. So to get the arc length by itself, I'd multiply by 5 on both sides. So of course it would cancel over here. And then I would do 3 pi divided by 7 times 5. So 3 pi divided by 7 times 5. And that would leave me with 6.73 for my arc length. And that's it.